Hi guys, this is Objective 5.5 where we're going to apply trigonometry in a variety of contexts. We're not going to do the cofunctions piece in this video, so don't worry about that. But basically this is like, we learned 5.4, right? And we learned kind of a bit about what trig is. Now we get to apply and see when trig becomes useful in real life stuff. So let's start with vocab. So trigonometry is again that study of relationship between angles and sides in triangles. I want us to write down SOHCAHTOA. Those are our trig. Remember, sine of an angle is equal to the opposite side divided by the hypotenuse. Cosine is equal to the adjacent side by the hypotenuse. And then tangent of an angle is equal to the side opposite the angle divided by the side adjacent the angle. So that's we learned with trig. Complementary, we're not going to worry about that word actually today. Horizontal is when we're thinking about kind of a surface or a segment that's like flat, left to right. And then elevation is going to become important today, and that means going up. Okay? So we're going to actually skip over page 1. So in my class, we're not going to deal with cofunctions right now. We're going to skip over that. We're going to jump straight to something called angles of elevation and depression, okay? So I'm going to talk to you about this situation where if you're outside, you're chilling outside, and you look up at a bird, right? That's something that happens all the time. We look up and down all the time in our lives. And guess what? What is exciting about this is when we're looking up and down in life, geometry shows up. I'm going to show you how today. I'm just looking for my straight edge. Where are you, buddy? Oh, there it is. Sorry. Okay. Just grabbing it. Okay, sweet. So, if I'm a person, I'm looking up at this bird, right? Bam. Okay? When I'm looking up, my line of sight is there, right? It's like this, like, usually it's like a diagonal up, right? If I'm looking just straight, that's a horizontal line, right? Like if you're just looking this, so like, I don't know, I'm gonna use a penguin, ready? So if I got a penguin here, right, and he's looking straight, right, so he's in this situation, he's looking straight, his line of sight is here. The minute the penguin looks up at the bird, right, it creates an angle, right? The angle's kind of like right there, looking up at the bird, like, oh, hey, other bird, what's up, right? Straight, looking up at the bird, right? This angle that's formed right here, I'm gonna call it theta. We call that the angle of elevation. Okay, so we're going to jump to our key points box. So we're going to skip over all these questions, guys. I'm just going to show you this, okay? So, jump to our key points box and talk about the angle of elevation is the angle formed between the horizontal, so when you're just looking like straight in front of you, and the line of sight when an observer looks up. So basically, if we've got, like in this situation, we got this dude trying to look up at this bird, okay? So straightforward is horizontal. And then the line of sight, right, as he looks up is right there. As dude looks up, this angle that's formed is the angle of elevation. Okay, so the angle of elevation is this as the dude looks up. Again, as dude looks up. Okay? So, then, what's dope about this is look, this situation, as someone is looking up, look what gets formed. If we're looking up at something, we think about like the height of the thing, right? And we're looking forward. What gets formed? A right triangle. So what's cool is if we have situations, I'm going to go over a situation. For example, if we have like the angle of elevation to the top of a tree, so angle of elevation to the top of a tree from a spot on level ground, 35 feet from the base of the tree is 40 degrees. Okay, so we've got this tree here. We're going to sketch a tree, right? The angle of elevation to the top of the tree from a spot on level ground. So ground is like our horizontal. horizontal dealio, right? And then the angle of elevation to the top of the tree. So we're thinking like the top of the tree, right? This is our angle of elevation, is 35 feet. Is 35, or sorry, not 35 feet, sorry. The problem said it's 40 degrees. So I'm drawing out the situation, right? That's my angle of elevation, okay? What is the height of the tree in feet rounded to the nearest whole number? Well, guess what? This situation, if I'm thinking about the height of the tree, right? This situation forms a right triangle. And I was told that the spot on level ground 35 feet from the base of the tree, 35, right? So what's the height of the tree? That's that dimension right there. Okay? Technically, I should move my tree over a little bit. It's the base of the tree, so pretend the tree is here, okay? And that's the base of the tree. All right? So what's cool here is, first of all, this is a situation that like shows up in real life where a right triangle gets formed. And then if I have an acute angle and a side length, I can use my SOHCAHTOA that we learned in the last objective to solve for this. So if I think about, okay, well, this is the side opposite the angle. This is the side adjacent. This is the hypotenuse. Okay, well, I want the side opposite. I'm given the side adjacent. That's my TOA, right? So tangent of 40 then is going to equal opposite over adjacent, which is x over 35. I'm going to solve this equation by multiplying by 35. So x is going to be equal to 35 times the tangent of 40. What is the height? What is that? And rounded to the nearest whole number. So let me put that in my calculator. Clear, 35. Tangent of 40 is equal to about 29 feet. See that? Cool. All right. I'm going to skip over example 4 for now. I think example 4 is, it's kind of the same idea as this. And next I want to talk to you about angles of depression. So let's go back to this situation. Okay, let's pretend the bird is looking down at the person. The bird's up here. Okay, the bird is looking forward. So what up, penguin? Okay. And then the bird is looking down at the person, right? The angle that's formed right here as like the bird is rotating its neck, right? So again, if the bird is looking straight, right? The line of sight is just straight out in front of it, right? Once the bird looks down, this angle is formed, right? Notice it's not this angle inside the triangle. It's outside here because it's basically the angle from the horizontal, right? So this is called angle of depression, where the angle formed between the horizontal and the line of sight, the diagonal line, right? When an observer looks down. So back in this situation, right? So if you've got a bird, if it's looking horizontal again, right? And then when it looks down, right? That's that angle of depression. Okay? And you might notice something when you look at this shape. We've dealt with this before. This is called a transversal. Where the line of sight is our transversal, our horizontals are our parallel lines. These are alternate interior angles, so they're going to end up being the same. So the angle of depression and elevation between two objects are congruent. Because basically, again, we're forming a transversal here where we're basically talking about these two angles. This is my angle of elevation as I look up at something. This is my angle of elevation as I look down on something. These would be parallel lines. They're alternate interior angles that are going to be congruent. So they're both going to be the same. Okay? So what's cool about that is if, like, let's pretend we're looking at a situation where Titania is at the top of a lighthouse, which is 250 feet above sea level. Top of a lighthouse. So I'm picturing kind of like a lighthouse here. Oh God, that's my lighthouse. It's 250 feet above sea level. So like this height, right, is 250 feet. It's 250, right? From the top, the measure of the angle of depression to Bryce's boat on the water is 48 degrees. All right, so we're going to imagine a lighthouse, right, is on water. There's a boat. Oh, God. Here's a boat. Okay? And again, if I'm standing at the top, my angle of depression, so I'm like chilling at the top, like, what's up? Yay, I'm at the top of this lighthouse, okay? Looking, like, and I'm looking forward, right? But if I'm looking down to the boat, this is my line of sight. Right, I'm looking down at the boat. My angle of depression is right here, right? This would be like my neck looking down, right? And then look, this is another situation where like a right triangle gets formed. Oh God, please be patient with my like terrible drawings, but like y'all get the gist, right? Okay, so bam, okay? Right triangle's formed, right? And it says the angle of depression is 48 degrees. Now what's cool about this is if we remember that the angle of depression and elevation are the same, to look up at the boat, that would be this angle down here. So this would be 48 degrees as well, right? So then we can still do, it's asking how far is Bryce's boat from the bottom of the lighthouse. So we're looking for this. So in this case, we can use SOHCAHTOA again. We're given the opposite side. Now we're looking for the adjacent side. So that means tangent of 48 is going to equal 250 over x. Now I need to solve the situation. I'm going to cross multiply because I notice x is in the denominator. So I'm going to get 250 equals x times the tangent of 48 divided by tangent of 48 on both sides. X equals 250 divided by the tangent of 48. Now I'm going to leave that as an exact answer because it didn't tell me how it wanted it rounded, so I'm just going to leave it exact. You see that? So like what this lesson is about, guys, is like situations where like these right triangles show up. And they show up when we look up or look down in situations. Okay? So last thing I want to show you is jump to key points box on page 6. Okay? So I'm going to go to this kite example. So take a second, read the kite example. So Richard here is flying a kite. Yay, he looks excited. When fully extended, the kite has an angle of elevation of 57 degrees. So an angle here up to the kite, going up to the kite is 57 degrees. If Richard is standing 100 feet from the point on the ground directly below the kite, so the point of the ground directly below the kite is like anywhere directly below, right? Formed by a vertical line. Well, hey, a right triangle shows up. He's standing 100 feet, so that's this far. And is holding the end of the kite string 6 feet in the air. So this is 6 feet. How high up is the kite? Well, how high up is the kite, is basically this distance plus this distance, right? Which is 6. So the new thing to notice here is we must consider the height at which the angle of elevation depression starts. So if we're trying to think of how high is the kite, that's this 6 plus whatever this distance is, right? So I'm going to solve for this distance using my SOHCAHTOA. So this is opposite, that's adjacent. So again, we're dealing with tangent of 57, because that's opposite over adjacent, equal to x over 100. Now to solve, I'm going to multiply both sides by 100. So I'm going to get x equals 100 times the tangent of 57. When I put that in my calculator, (100) times the tangent of 57 is equal to about 100. I'm going to round it to 154. About 154 feet, right? But if I want, again, the total height, I got to do 154. Whoa. 154 plus the 6 feet. Because the angle of elevation starts 6 feet above the ground. 6 feet up in the air. Okay, so the kite is actually 160 feet up. Okay? And that's it. Hope you liked it. Hope you got it. Have a good rest of your day.